Hi, in today's video we're going to take a look at running large language models using Ollama on our computer. We're going to take a look at a couple of models and also how we can get Emacs set up with gptel as a front end. So we're going to take a look at running DeepSeek R1, which was released yesterday, which is a reasoning model. We're going to take a look at deepseek-coder for analyzing code, and also Mistral, Zephyr, and what I want to show you now is the GitHub page for Ollama. You can come across to the models to search the models and to the GitHub page over here, which takes you to this section. And what this does is actually explain how you can run particular models and what system requirements you're going to need to run them. So we have a look at this model library down here. At the bottom, what it will say is you should have at least 8 gig of RAM to run the 7B models, 16 gig of RAM to run the 13B models, and 32 gig of RAM to run the 33B models. So I'm running this on a Dell XPS 15 2019 with a NVIDIA RTX 60, is it a GeForce 1650 graphics card and 16 gig of RAM. So I can safely run the 7B models. I have noticed some didn't work, but I'll get into that. So what we're going to do is actually take a look at getting this set up. And what we're also going to do is take a look at running gptel, which is a simple LLM client for Emacs, which will provide us with a nice front end instead of using the terminal. So what I'm going to do is switch across to Emacs here and run through the setup. Now I'm using Freebsd here. If I just switch back to the Ollama page, actually, what you'll notice if you come to the download section, what you'll see is there are downloads for Mac and Windows. And the way that Ollama works is it works with a server, and you have to run the models and they interact with the server. So this actually downloads the server, which you can then use to pull models down and run them. So on Mac and Linux, I believe you have a GUI program. On Mac and Windows, rather, you've got a GUI program. On Linux, it may be in your repositories. If not, you can install it with the following command. Now, I'm on Freebsd, so I'm going to take you through the setup on Freebsd to install the server, and then how you can actually run the models. So first of all, what we need to do is install Ollama. So this is on Freebsd, and I'm using DOAS here, so I'd run DOAS pkg install Ollama. That's it. That will install the Ollama package, which doesn't take a long time to download. And then we can move on to the next section. So to run Ollama, what you need to do is actually open 2 terminals. One to run the server, and the second one to either pull or run the model. So this is the note from the Freebsd package for Ollama. It has a message describing how to start it using this command. You can also run ollama-server to actually start the server. So this may be specific to Freebsd, I'm not sure. We have the Ollama num LL1 debug and llama debug 1, and then Ollama start. So what I'm going to do is actually come across here, copy this into the terminal, and start Ollama. So what you can see now here is Ollama is running, and what you'll see down here is things like Vulkan mentioned. So what we can actually do is come across to, before I start this up, what I want to do is actually show you a tip. If you run NVIDIA SMI dash dash loop equals 1, what that's going to do is display the output of NVIDIA SMI and loop the process every second. So it's not actually running down here as yet. You can see OBS is running. But once I actually get this working, what it will do is it will actually show you that the graphics card is being used with Ollama to process the queries. So that's it. We've started Ollama. Now, the next step is actually pulling down the models you want to run and then running them. So what I'll do is I'll just go through actually installing some of these models. So first of all, we have DeepSeek R1. So this is the URL for the page that I just showed you previously. So what we're going to do is pull it. So to pull the model, we would run ollama pull deepseek-r1:7b. So if I come across to the DeepSeek page here, what you'll notice in this pop-up is you have various sizes of models that you can actually run. So I have 16 gig of RAM, so I went with the 7B model, and you can see the file size down here is 4.7 gig. Now, the Ollama models are actually stored in your home directory in ~/Ollama. And because this directory can get quite big with all these models, what you can also do is you can symlink this directory to an external drive using ln. So you'd run ln-s, then the path to the external USB drive, and then to the Ollama directory here, because this basically can get quite big. So first of all, you would pull the model, and as I said, you can see here this 7B. This corresponds to one of these options down here. So remembering the notes, you need 16 gig of RAM to run a 33 B model. So theoretically, I suppose you could go for the 32 here, but I didn't. I just went for the 7B because it's quite a big download anyway. It takes an hour or so on my connection to download. So that's pulling DeepSeek R1 with a 7B. So that's going to take, depending on your connection, maybe an hour, hour and a half, something like that. Once it's actually downloaded, you can run it by running ollama run deepseek-r1:7b. Now at this point, I should mention how you can actually check what models you've got installed. And the way you do that is by running the ollama list command. And you have to run this command when the server is actually running. So ollama list, what you will see here is a list of the models that I've actually got installed. So you can see here we've got DeepSeek, Zephyr, deepseek-coder, and Mistral, and you can see the file sizes of those models as well. The reason why you want to run this ollama list command is because sometimes you actually need to run the models with the :latest option. Okay, so that's running DeepSeek. I'm not going to run it at the moment. I'm just going to whiz through the setup of the models. So that's DeepSeek. So next one is deepseek-coder, which is used for things like analyzing code. So you can give it a function or something and say, explain this bit of code to me. And the way that you would pull this is by running ollama pull deepseek-coder. You would then run it by running ollama run deepseek-coder. Okay, next one, Mistral. That's another model. I believe that's a meta model from our good mate Mark Zuckerberg. So ollama pull Mistral, ollama run Mistral :latest. I have to double check that. As I said, some of them you can just pull like Mistral, but then when you actually run it, you've got to run Mistral :latest. The next one we're going to take a look at is Zephyr. Okay, it's another language model. So Ollama pull Zephyr, and then Ollama run Zephyr. So what you can also do is actually check if the server is running by running pgrep ollama. So if I run pgrep ollama, you will see the process here. Now, if you want to kill the llama, not like kill a llama, kill ollama, you'd run pkill ollama. Now, the reason I'm mentioning this is because sometimes what will happen is, the server might stop, and what you'd just be tempted to do is restart the server. But what you actually need to do is, if the llama-server stops, the process may still be running. So what you need to do is check if the process is running, and if it is, kill it before restarting the server, because what can happen is you're trying to run the model and it's not working, but the server's running. And what's actually happening is the client, the thing that's running the model, is interacting with the old crashed process, not the new process you started up to run the server. So if the Ollama server stops working, run pgrep to make sure and check if there's a process running, and if there is, kill it before restarting the server. Now, another thing I should mention is, in addition to the command I showed you to start Ollama with those debug options, what you can also do is just run ollama-server, and I believe that basically does the same thing. What I've done is actually created a little script called ollama-server with the options provided by the Freebsd package, ollama num parallel debug, and then ollama start. So I've been using that instead of ollama-server, and I'm basically starting the server using this script, so I don't have to type it out every time. Okay, so that's notes on ollama-server. Yep, so as I was saying, you can start ollama-server with the following command. So what we're going to do now is actually run some models and interact with them. Just get some tea there. What I'm also going to do actually is show you Google Gemini. So what you can do is you can come across to this page when you are logged in. You can see that is me. So what you can do is you can come to aistudio.google.com at API key. And when you are logged in, what you'll see is this little thing here, create API key. So click that, and then it will come up with the API key, and you click this thing here and you can copy it to the clipboard. Okay, so the reason I'm mentioning that is because what I'm going to do is I'm going to show you Gemini as well. And let me just come across to this section here for gptel. So with Google Gemini, what you can do is actually use that token that you've just created with a authinfo file. So let me just zoom this in a bit. So in your .config Emacs directory, what you can do is create a .info file. I think it should be let me just check. Yeah, okay, that's fine. Yeah, .authinfo. And in that file, what you can do is add this bit of code that will connect to the Gemini server. So you run in the authinfo file, you would add machine generative language.googleapis.com password, and then the token. So what I'll do is actually show you Gemini working as well, so that we also have a online version as well as our offline versions running llama. So let's go back here and let's org tree slide mode, come out of that. And what I'll do is I'll run Mistral first, and then deepseek-coder, and then deepseek R1. So what we're going to do is run, let's just zoom this in a bit. So that's annoying. It doesn't zoom the actual it's not zooming the actual code block here. So llama run mistral latest. So again, what we have is over here we have the ollama-server running. So this is a good use for something like Tmux, because you will need a couple of terminals open to get this working. So we've already pulled the model. You see ollama list. So what we can do is run ollama run mistral latest. What you may find is you get this error sometimes. Error posted at EOF. So you can see llama-server is running. That is the name of the server. So if we just run this again, you can see it's now connected. Don't know why that happens. It just happens occasionally. Also, the other thing that can happen is sometimes you will try and run a model and the server will crash. And if you have a look in the messages, in the debug messages, you will see that the GPU may have run out of memory, in which case you can't run the model. As I said, you may also get occasions when you're doing this, the server crashes. Don't restart it straight away. Check if there's a process still running. If there is, kill it, then restart the server. Okay, so we have Mistral running. So you can see here, these are the available commands. But what I'm going to do is I'm actually going to step this up a notch and use Emacs. So what I'm going to do is come across, and what I'm going to do here is actually take you through the configuration for Emacs gptel. So I've installed the gptel package install. It won't list it, but I'll do package install. It's already installed. Package list packages. gptel. Okay, there we go. You can see next one down. gptel interact with ChatGPT or other LLMs. Okay, so this is going to be the setup for gptel. Okay, so we've got gptel over here, and this is a front end which is nicer to use than the terminal, and this is a list of the LLMs that it can use. You can see we can use ChatGPT, Claude, Gemini. So this is Google Gemini, which I'll show you, Llama running locally, and all these other options down here as well. So what we'll do is actually take you through the setup for gptel, and well, let me show you what it looks like first of all. So there are a couple of commands that I need to take you through. So first of all, if I come to gptel menu, I think it is, that is going to bring up this screen. And what you can see down here is I've already got it set to the correct model that I'm running. But what you can do is type -m, and that's going to bring up list of models, and basically let you run the model. Now, the thing with this is you need to be running the model in the terminal before you can use it in Emacs. And if you want to switch models, you're going to have to stop the model and then start a new one. So what I'm going to do is press Control-G to dismiss this screen. And then I'm going to run gptel like this. and it's going to say create or choose a gptel buffer default ollama. Okay, so now what this has done is it's given me this new screen. You can see up here ollama ready and a prompt. What I'm going to also do is show you how we get this set up to be displayed in one window. By default, this window would be displayed in a split window. So the default setting is that Llama and Gemini, they all are displayed in a split window down here. And the issue is, the problem is you then have to run Control-X, Control-O to switch focus from this window up here to the one in the bottom. And you kind of, what's the point having half a window? So I've set this to be displayed in one window, and I'll show you how that's done. I want to have some more tea. And what I want to do is show you these options up here. We can see the model that is being run in here. And we've got this section here that says prompt. Now, if I click this, it's going to come up with this little window down here. Your large language model living in Emacs and a helpful assistant respond concisely. And you can see these options down here. These keyboard shortcuts correspond to different prompts. So we've got the default, which is this one here. You are a large language model living in Emacs, a helpful assistant respond concisely. We have a programming prompt. We have a writing prompt and a chat prompt. I haven't really looked at the chat prompt too much. I've been focusing on these three here. So a default prompt, I suppose this would be more when you're asking a general question. So let's give it a sort of question, and then what we can do is have a look at the programming and writing sections. So let's say, what is the website for the BBC? What I'm now going to do is press Control-C and return. And what that's going to do is actually, as long as it's running, yeah, I can see it's actually stopped running. So that's good. It's good sometimes for an error to happen so that I can show you how to fix it if you encounter the same issue. So it was taking a little while to actually kick in, which made me think, okay, it's not working. So you can see the server has actually stopped, but we can see we still have the prompt here from running Mistral. So what we're going to do is type /by, okay? Now we're going to come across to this terminal here and run pgrep ollama. You can see ollama is still running here. So that's why I was mentioning this pgrep pkill situation. Pkill ollama. Okay, so we're killing it. And then we're going to run the server again. And then we're going to run Mistral again. Okay. Again, we're getting that error. Don't worry. Run it again. Kicks in. Now we can switch back to Emacs. So occasionally that will happen, and that's how you fix it if it does. Now, what I'm going to do is run Control-C return. Okay, the official website for the BBC is bbc.co.uk. Yep, that's right. So that's just a simple query. I could go through and do more, but I'm not. I'm going to switch and show you the different prompts. Now, I think there is I can remember the keyboard shortcut for this. Is it? No, that's not it. So this is the, I think that's the gptel this menu. So that's gptel system prompt. Yeah. No, that's not the system prompt. Okay, so if you're in visual mode here and you press Shift Return, that's going to bring up this menu here, which we used to set the model. What we actually want to do, we can either press this, change it, but I think the thing is gptel system prompt. Yeah. So gptel system prompt. So let's try the programming. Okay. So what I'm going to do is just get it to output a simple hello world script. So create a sh shell script that echoes hello world. I then press Control-C return. Okay. And what you'll see here is it has created a org source block. It's actually set the language to bash, but it's set the shebang to sh, and you can see it's echoing hello world. So that's the sort of programming. I'll show you more on the programming side using deepseek-coder, which is a better fit for analyzing code and that sort of thing. So let's switch to the writing prompt. So what we can do is things like summarizing text, that sort of thing. So let's see if we can find a bit of okay. So what I'm going to do is just copy this, and what I'm going to do, just define it, is say summarize this text as a pirate. Okay, so matey, the Zephyr be a swashbuckling series of improved models based on mistrals and mixtrals, all training to be our loyal scallywags on the high seas of help. So not useful, but amusing. What you can also do is summarize text or rewrite text. So you can basically give it a chunk of text and summarize it. So let's see if there's any text on here I can, any big blocks of code that I can summarize. So let's take this block of code here and say summarize this, or something like summarize this text, paste that in, Control-C-E, if that will do anything. Okay, there we go. So this is good because it's going to show you the speed that it's kicking stuff out. Okay, so there we go. So that's Mistral. So the other thing you can do is this is actually a buffer, but you can save the buffer as a org file. And I'll show you in the setup how you actually specify the default option to use org mode. So let's kill that. And what we're going to do is actually come across here and exit will go by. So what we want to do now is we want to run deepseek-coder. So we're going to run llama run deepseek-coder. And again, you can see here what's happened is I've got this EOF error, and you can see down here in the second tab, llama has actually stopped running. Again, it's useful that it did, because then I can show you the procedure to actually fix it. So remember, 2 steps, pgrep ollama. If you're running on a different system, a Mac or Windows, you're going to use the equivalent commands to actually check if a process is running and kill it. So pkill ollama, and we'll then just scroll back through our shell history and restart. You can see it's now restarted here, and we'll run deepseek-coder. You may get that error again. You run the command the second time, and it will kick in and start. So now what I'm going to do is switch across to Emacs here, and I'm going to run a GPT menu, gptel, oh come on, gptel menu. And what I'm going to do, you can see it's still set to Mistral. What I'm going to do is press -M, and then I'm going to write deepseek-coder, deepseek-coder, llama deepseek-coder. I'm going to dismiss this window with Control G, then run gptel, press enter, and you can see now I have a llama ready. We're running deepseek-coder, and we've got the prompt. So what we were going to do is actually set the prompt to programming. So what we're going to do is take a look at a function. So let's grab a function and have it explain what the function does. Okay. Explain the following code. Now, what this is it's Lisp code for Emacs, and what it does is it displays the Gemini buffer in the same window. So just as I'm running, let's actually do it the llama buffer. Actually, okay, okay, make more sense. Okay, as I was saying before, the default layout for gptel is actually to run a split window. And what happens, as I said, is the focus remains on here and it comes up in a split down here, and you've got to run Control-X, Control-O to switch to the split before you can interact with the window. It's really annoying, and also means you're just using half the screen, which is stupid. So what this bit of code does is it uses add to list, display buffer a list, any buffers called a llama, display them in the same window. So if we run Control-C, enter, okay, you can see here, this is how fast this is actually splitting this out using deepseek-coder. Okay, so this line of is defining a new buffer display function for certain special buffers. Let me break it down and explain each part in detail. So this is basically attempting to explain what this does. Okay, whether the buffer needs the same window, whether we want our new frame. So yeah, that's basically the gist. It's, you know, going to explain that stuff to us. We can give it another prompt. So let's give it a prompt to. You could give it something more complicated, but I'll just do write a sh shell script that echoes hello world. Control-C, return. Okay. So I have no idea why it's doing that. It didn't do that before. That's interesting. Didn't output all that stuff before it actually got it right. So you can see here it's actually yeah, that's weird. Let's try that again. Create a shell. See, I specified sh so that it would actually put the shebang as sh instead of bash. Let's see what shell script that says hello. Yeah, not sure why it's spitting out nonsense like that now, but good to know that it can just print out gibberish. So we'll take a look at some other stuff. I have found it quite reasonable for sort of analyzing code, and before it was outputting a simple shell script correctly, so I'm not sure why it's doing that. That maybe don't know if that's something to do with my setup. But what we'll do now is we'll take a look at DeepSeek R1, but what I want to do is actually show you Google Gemini. So what I'm going to do is I'll close this one, and I'm going to run gptel system prompt. No, system gptel menu -m Gemini. So we're going to run Gemini -1.5 flash. Dismiss that. gptel. Okay, Gemini. So this is Google Gemini. We have a option here to include media in the prompt, which I haven't looked at, and I'm not sure if that will allow you to sort of analyze media and that sort of thing. We'll come across to the prompt here, and we'll just set it to default. And again, with that, we set up our token on that page. And what I want to do is come across here and run Chromium. Okay, so if you're logged into Google and you come across to gemini.google.com/app, you can actually run queries. And what I wanted to do is explain that there's a difference between Google Gemini running in the browser as opposed to actually using the terminal or Emacs to interact with Gemini. That it has different capabilities. So for instance, let me come across to, I think it was Emacs, Gemini. What was it? Where did I put it? Maybe it was in Google. Right. Okay, Google Gemini. Okay. So what you can do is if you come across to the settings down here and extensions, the productivity section, I believe, is just for the people with a Google Workspace account at the moment. But these are the things that it can actually query: Google Flights, Hotels, Maps, and YouTube. So what you can actually do is ask it things about a YouTube video. So I can say, give me a summary of this video. Okay, so you can see here what it's doing. It's interacting with the YouTube API to actually get information about the video, and what it can also do is give you key points. You can see it spits out the video here. See if I can get this button to want it work. It might not. Okay, it's spitting out the same thing. Okay, yeah, I can do. I had different prompts that I actually had working, but I just wanted to see if I could get this to. Okay, connecting. Right. This is what I wanted to show you, is using different prompts. What you can actually do is get key moments from the video. And the way this is done is it's analyzing the transcript from the video that's automatically generated and pulling out key moments with the timestamps. I did actually manage to get it to generate URLs with links to that section in the video before, but for some reason it's not doing anymore. But what this will do, as I said, it will actually give you the timestamps of key moments in the video. So this could be useful, you know, if you want to generate a little bit of text to post on a social media thing describing what the video is actually about, it will come through. But the issue is some of these timestamps aren't completely accurate. Like they'll be in the right ballpark of 30 seconds to a minute. But I just wanted to show you how Google Gemini works in the browser as opposed to using the terminal or Emacs. And what you'll have down here is you'll have these options like share and export. So you can share the conversation, which will actually create a URL to this conversation that you can give to people. You can export to docs. When you do that, it doesn't export the embed. It will just export the text, and you can draft it in a Gmail. And the other options you have down here are copy, so it will copy everything. You can listen to it. So that's Gemini in the browser, and I just wanted to show you what that looks like. So if I come down here, and for example, try and run the same prompt, what will happen is it will say, I lack the ability to access external websites, including YouTube videos, therefore I cannot summarize the video. So there is a difference between how Google Gemini works in the browser as opposed to accessing it using a token you have created and a front end like gptel. Okay, so again, we've got a prompt here. So what I can do is I can give it a very specific thing. What I'm going to do is say, what's the first line spoken in the TV series Cheers? I'll have a beer. No, it's not. See, that should output I'll have a beer, and it did before. That's actually obviously the name of the line from the theme tune. What's the first line in the TV series? Yes, did we get it right? No, again. So that's the thing with this. Sometimes with these models, you'll enter a query and get it right. You come back, you try it again, and it's like it's got dementia and it's completely forgotten what you asked it. So it can be like talking to an elderly relative who forgets what you said 5 minutes ago. But I just wanted to show you some sort of basic prompts like what's the website for ITV, itv.com, yeah. Okay, so let's do the writing. So let's write a brief history of Newcastle United Football Club. There we go. So this is actually correct. The majority of people think that Newcastle was actually started in the 1890s. What was that, 1892 or something? It wasn't. It was actually started back earlier in 1880s, where there was Newcastle East and Newcastle West, and they sort of joined to become Newcastle. So that's correct. Let's come across to programming, and what's a write a shell script that outputs hello world, Control-C, return. There we go. You can see how quick that is, and how much better it is than the other model I was showing you. I think that was deepseek-coder, where it was outputting sort of a load of nonsense in the script, and I'm not sure why that was. So that's why it's useful to also have an online version, because basically the issue with these models is, say the model was released a couple of years ago, it's only trained up to the point that it was released, as it were. So it doesn't know anything after that point, if that sort of makes sense. So there's programming. So let's give this test here. Explain this code. Paste that in. Control C, enter. Okay. This is Emacs Lisp code. It modifies Emacs behavior how buffers are displayed. Let's break it down, add to list. So you can see that here, this is how it's breaking this down and explaining it. So the end, it's giving a sort of a shortened recap saying, in short, this code configures Emacs so that any buffer that contains a llama will be opened in the current window instead of creating a new window or switching to another window, which is absolutely correct. So what we'll do now is we'll have a look at deepseek-coder in a second, but what I want to do is actually go through and show you the setup for getting this working with Emacs. The first thing you need to do, as I said, is install the gptel package. And what we're then going to do is add this block of code down here. So first of all, we've got the auth source. So require auth source, add to list auth source, expand file name dot authinfo user Emacs directory. So that means the .auth source and .auth info file is stored in my .config Emacs directory. You could set this up with GPG so that it's encrypted, but I didn't bother because I didn't want to get sidetracked by having to encrypt things. I just wanted to get on with getting all of this working before looking at that. So that's the and again, this is the syntax for the authinfo file: machine generative language Google APIs.com password, and then the token that you got from this web page up here. And I believe you can do something like 15 queries a minute. So it's got a good limit. I'm using it for free. So unlike a lot of these things, you're going to get billed if you go over a certain amount of tokens or usage. With the Google one, you'll be all right. And let me just actually give you an example. So let me just come back to gptel, gptel Gemini programming. So one use I did actually come across with this before I get back into the init.el is I wanted to select a whole buffer in Emacs. So the keyboard shortcut slipped my memory, slipped my mind. So instead of kind of searching for stuff using Google as you would normally, which can be a pain because search results and search results these days are pretty terrible. So this is actually quite useful because you can say Emacs keyboard shortcut select whole buffer. Bang, Control XH, Control XH, there we go. So that is one thing why these assistants can actually be useful. You can say Emacs org mode keyboard shortcuts. There you go, and it's going to spit out a list of keyboard shortcuts. So that's actually quite useful. So that is one example of where it can come in handy. As I said, the Google Gemini results are going to be fast, and obviously this is tied to your account because it's using a token. So there are sort of privacy concerns, but it's the same as if you're actually just using Google. So it's not really that much of an issue. So what I'm going to do is kill that and actually switch back to the init.el. So that's the first step. Is this section here is only required for using Google Gemini. Okay. So what we've got down here is the gptel setup. So what we've got here is required gptel, required gptel curl, required gptel transient, And then what we have down here is the gptel config. So what we've got here is require gptel default mode org mode. Otherwise, I believe it's going to use markdown. gptel response function, gptel end of response. And then we've got gptel expert commands, which actually gives you extra options in the menu. So that's the gptel setup. Then what we have here is the section for Google Gemini. So what we're doing is using seq gptel model. Now, this is something I want to mention. This is how we are specifying the model. And what I want to do is actually come across to this section here, because this isn't actually very clear. And so let me scroll down through here. So there is a section down here. Can find it. Okay, let me search for it. Okay, yeah, this section down here. gptel model is now expected to be a symbol, not a string. Please update your configuration. This had me stumped for a little bit, and I had to look through the GitHub issues, because what you'll find is in a lot of people's config, what it will actually be is an old config where they were using a string, and this was actually enclosed in double quotes. The name of the model was actually enclosed in double quotes. And what that means is it needs to be a symbol, is it needs the comma in front of it, which denotes that it's a symbol, and this is the name of the model. So that's one thing that can sort of stump you first of all. Then we have gptel backend, and we have this thing here says gptel make Gemini, and then Gemini up in here, and this is going to actually give it the name of the buffer. Then what we have down here is key, gptel API key from auth source generativelanguage.com. Okay, and what that does is that actually corresponds to this generative language .google.apis.com in the authinfo file. So what that basically says is, look in the auth. What it's going to do is look in the authinfo file for this string, and then use the token from it. And the stream T basically means that it's going to sort of stream stuff into the terminal straight away, into Emacs. Then what we have is the display Gemini buffer in the same window. So this is the add to list display buffer a list Gemini here. So what you can see is the Gemini buffers actually start with Gemini like this. So hence the caret. That's basically it will match anything that starts with Gemini. And then we get it to display buffer same window, so that it's not displayed in a split window. Okay, so that's the Gemini setup. So this is the Ollama setup we've got here. So what I've basically done is set particular models here. So what you'll see is seq GPT model, and then the name of the models, and what these are symbols. So these correspond to the output from the ollama list command. So if I was to open a terminal here, ollama list. Okay, so llamas stopped running. So by kill ollama. Ollama list. Okay, so these are the names of the models that we've got installed down here. You can see 7B, latest. So those all correspond to the names of the models that we pulled down. And what we're doing down here is saying gptel backend gptel make ollama, and this is the name of the buffer. And then what we've got down here is the host. So this is local host, and this is the port that the ollama-server runs on, which is 11434 stream T. And then in this model section down here, what we have is the list of models. So we've got Mistral, Zephyr, DeepSeek, R1, and deepseek-coder. And then finally, what we have is display the ollama buffer in the same window using the same code that we did for Gemini, so that it will take any buffer called ollama and display it in the same window. Finally, what we've got down here is a gptel post response function. And what this basically does is some models output shellcode org source blocks with bash by default. And what this does is it converts it to a org source block using sh as the language instead, because I don't run bash, so I don't have it installed. So I want it as an sh. So that's the setup for gptel. So what I'm going to do now is actually run deepseek r1. So what we have here is llama running. And what we want to do is come across here and run deepseek. So we're going to run ollama run deepseek-r17b, which is the model I pulled down. And this may give us an EOF error. Okay, you can see EOF error. Run it again. Sometimes what will happen is it will hang here. All right, okay, connected. So I could show you stuff in the terminal, but I'm not using the terminal. I'm using Emacs. So, you can help. You can set session variables, show, load, save, clear, all that kind of stuff. But I'm going to show you this in Emacs. So what we want to do is run gptel menu -m deepseek r1. Now we've got that set up, we can close that with Control B, then run gptel ollama, and we've now got programming here. So what I'm going to do is actually give you the same code and show you how deepseek r1 works with programming. And this is a reasoning model. So this actually thinks things out. It's like having a little brain inside your computer. So what I'm going to do is say, explain the following code. Okay, you can see we have this set to programming. With the cursor down here, I'm going to press Control C, enter. Think. So what this is doing is it's rather than having a kind of database of sort of function stuff, what it's actually doing is it's looking at this and thinking things through based on some knowledge that it's actually got. So you can see here, so I've got this line of Lisp code here. Let me try and break it down. First of all, I know in Lisp, add to Lisp is a macro that adds an element to a list based on a predicate. The general form is add to list predicate list element, right? So looking at the code, display buffer a list must be the list item name because it's using single quotes around it. Now inside parentheses, after display buffer a list, there are two elements, llama display, buffer same window, and nil. Wait, why is there a second element? I think in Lisp macros like add to list, multiple values can be returned by the predicate. So perhaps this line is checking something that returns multiple values. The first part is a llama, but without quotes around it because of the single quote. Wait, no, looking again, actually written a llama. Maybe there's some escaped characters involved here. I'm not sure about this syntax with asterisks, mechanics, so maybe that needs some research. Putting that aside for a moment, the second part after the comma is display buffer same window, which seems like a functional variable name. Okay, so this is getting deep on this. It's actually thinking things through. So let me just scroll down here. Okay. So putting this aside, it's saying add to buffer display a list a new entry if the object satisfies certain conditions, a llama, which display buffer same window as part of that entry. I'm not entirely confident about all parts, especially the llama syntax. Maybe that's really some kind of filter or condition in this context. I should probably look up what a llama does in this, whatever environmental running this is running in. Also, why have two elements? Normally add to list would expect a single predicate value. So this is, rather than sort of spitting stuff out from a load of examples it's got, is kind of trying to think things through and work out what this actually is. Okay, and the other thing to mention is you can actually see the speed it's actually outputting stuff. So this again is a Dell XPS 50 in 2019 model running a RTX. It was a GeForce 1650. And what I can actually do is run NVIDIA-SMI-loop equals 1. And let's stick that here. What you'll see is the process llama-server, and you can actually see the query being used there. Okay. So you can actually see that it's using the GPU for the llama-server and the query that is actually running here. So again, this is deepseek-R1, the 7B version, and this was released yesterday, and it was a 4.77 gig download, and this is really very interesting, as opposed to the DeepSeek coder. So what we've got down here is a breakdown of what's actually going on here. The provided Lisp code adds an element, the list name display buffer a list is based on specific criteria. Here's a step-by-step explanation. Function add to list. This macro adds elements to a list if they meet certain conditions. Parameters display buffer a list, the list where the element will be added. A llama display buffer same window, a predicate that returns values used for adding elements. Nil, an additional value passed to the predicate which may influence conditions. Predicate check, likely a condition checking something related to a llama, possibly involving regular expressions or specific object properties. So that is correct. That is a regular expression. The caret checks for the beginning of the line. Display buffer same name, the actual element added to add when the conditions are met. Purpose adds an element display buffer same window to list buffer display a list if the associated objects satisfies the condition. This code efficiently filters and adds elements based on criteria used for dynamic data management within a Lisp environment. So did a lot of stuff there, but you actually see the deepseek-coder one actually gave a different answer, a different kind of answer, and it actually got it right where it was explaining what the actual function did, that it set the window to be displayed in a single window as opposed to a split window. So that is the prompt. So let's write a, I think there was a Fibonacci script, Fibonacci sequence. Yeah. So what we can do is do something like write a shell script that outputs the Fibonacci sequence Okay, I'm just wondering if this has crashed. No, still running. Okay. So this is a different kind of model as opposed to the deepseek-coder. It's something that can actually reason things through, so it will actually think things through. So deepseek-coder may sort of output stuff a lot sort of quicker with the with the hello world thing where it kind of mangled everything. And again, this is all displayed in a org buffer, and you can actually save these conversations as an org file, and you can then actually resume the conversation as well. So you can see this is taking a while to actually go through, and it's actually trying to think things through. So we're going to leave this to run. But I think some of the advantage of using Emacs is that, as opposed to using a terminal, everything's actually output in a sort of text file like this. Whereas the issue with the terminal is, unless you're running something like tmux, it's going to be difficult to scroll back and select all the text. You're also going to have much nicer formatting of the text in Emacs as opposed to running in the terminal. The other advantage is actually you can easily change the prompt, set additional options with a nice sort of GUI. So again, this is thinking things through. Okay. So this is thinking about the Fibonacci sequence, and a side note, you ever watched the series Prison Break years ago? I think one of the characters was called Fibonacci. There may have been sort of like an alias. It was all right for the first couple of series, then it went a bit funny. It was a trash, really, but it was good trash to watch anyway. So here we go. What we're doing here is we're actually seeing it echoing out some code. And the interesting thing is it's actually not putting this in a org source block. So the other issue with this is you may need particular functions to work with particular models to change the output of the code. For example, some models will output links and things like that as a markdown syntax. And I believe there is actually a bit of code I came across somewhere, which I can't remember where I saw it, that would actually use pandoc to convert the output from markdown to org mode. So you can see here, this is really giving it some sort of trying to figure this out. But I just thought it'd be interesting to actually show you how quickly this actually generates the text and actually figures this stuff out. Again, this is DeepSeek-R17B model. Sometimes what I found is in theory, you should be able to run a particular model based on its size, but that's not always the case. For example, I tried to run some of the code llama coder 7B models, and they wouldn't actually work. I didn't have enough sort of power in the GPU. So sometimes what will happen is just because you can pull down a model doesn't mean you can actually run it. So sometimes you will pull down a model and go to run it, and what will happen is the server will crash. And if you look in the debug message in the terminal, what you'll actually see is an error related to Vulkan and an out-of-bounds memory issue with your GPU. And basically what that means is you don't have enough power in the tank to run that particular model. So if you're getting an issue where you got the server started, you try and run a model, crashes the server, you try and run it again, it crashes, look in the output, and you may see that you just simply don't have enough oomph to actually run that particular model. So you're going to have to move on and try something else. Again, as I showed you, sometimes you will get EOF errors when you're running a particular model, and just running the command again will actually get it to work. Even if you leave the server to run for like a minute, you'll still get the error. So again, the other thing, as I showed you, if the server does actually stop working, what you need to do is check there's no processes running. There are, kill it, and restart the server, because as I said, otherwise what can happen is you don't kill the previous process, you'll have the server running and you'll be trying to run the model and it's not working, you'll be baffled. And as I said, that is because the model running is trying to interact with the old server process that crashed and not the new one that you just launched. So this is still thinking. So you can see this is really quite deep in how it's going about this, which is something that makes it particularly interesting, and sets it aside from some of the other models I've actually been looking at. It's reasoning things through. It's actually thinking, as opposed to, it seems like with some of the other models, it's just kind of almost like a sort of web search, where it's got a list of Stack Overflow answers or something like that, and it's querying those and pulling out bits of code that it sort of recognizes from those answers to output a response. Whereas what this is doing is actually going through and actually testing all of this. So this is actually going through and testing this code and sort of thinking, oh no, that's not working. Maybe if I do this or do that. So yeah, this is taking a long time compared to so many other things. I think I tried deepseek-coder and Mistral generating the Fibonacci sequence, and it did actually output stuff reasonably quickly as a block of code. Whereas what this is doing is slightly different. It's actually reasoning things through and kind of taking little blocks of information and putting them together and trying to think things through and then actually testing it. So I haven't tried this particular prompt with deepseek-coder before, deepseek R1. I've only been using this for about 2 days, and a lot of that time was actually spent pulling down models and pulling down models that didn't actually run. So that can be an issue, is that the models are quite large. So there's two issues that sort of come up, is one, how long it takes to download them, and two, the amount of disk space you need. And as I said, the models, at least on Unix and Linux-based systems, will be stored in ~/.ollama. And what you can do is you can create a symbolic link using the ln command. So you'd write ln-s, the path to the source, and then the path to the destination. So that would be ln-s and the path to your external drive, and then the destination would be ~/.ollama, and that would allow you to keep all these large language models on an external drive with more disk space. Obviously, you would need to mount the disk before starting a llama, but that's one way around the actual issue that might crop up. So that's where everything is stored. So another thing is, what you can do is, while it's chugging away, you want to list the models. You run ollama-list. That outputs the list of the models you've actually got installed that are installed in the .ollama directory. And to remove a model, you would run ollama-rm and then the name of the model. So ollama-rm mistral : latest would actually remove the model. So it's pulling the models is, although it's a completely different thing, it almost feels Docker-like, because what you're doing is you have a repository of models that you can pull down from, just as you would with sort of Docker Hub, or I think it's called Quay, and you'll actually see the process of it downloading everything. The other thing to mention is, when it's actually downloading the models, it will absolutely cane your bandwidth. So it will saturate the bandwidth completely and use all available bandwidth. So you won't be able to watch YouTube videos or anything like that, because on my system, what it was doing, it was actually pulling down about 1 meg. And basically what that meant was, even you couldn't watch YouTube videos, even set to 144p. It would sit there buffering for ages. So what I would recommend is, if, for example, you want to watch something while this is processing, would be to actually download some things offline, so you can actually watch stuff as this is downloading, because otherwise it's extremely annoying. Even web pages will struggle to load when it's pulling down the models. So what we've got down here is, it seems to be sort of finishing up, and you can see it's actually written a source code block above that, and what it's doing now is it's actually explaining the script. So this is the explanation of the script. The script first checks if no argument is provided and exits with an error message. Oh, nice. It then prints the initial two Fibonacci numbers 0 and 1. Variables A and B are additionalized to 0 and 1 respectively, using a loop from 2 to the specified number. And each new item is calculated, and it's going on here. So it's outputting the stuff. So what we're going to do is, we're actually going to try running this afterwards, after we've actually had a little read of it. So there you go. You can see now it's actually finished. Okay, so here we have got a shell script. So what we're going to do is actually just copy this. And what it hasn't done is actually provide a... it hasn't provided a shebang. So what I'm not sure about is actually if there are any bashisms in this, because bash has a sort of different syntax. So Fibonacci, right? Paste that in, and it may be that I don't know if it's actually generated a okay. So let's have a look at this. Except input for the Fibonacci. So if no, if nothing's provided, exit. So A and B. So let's see if it actually. Fibonacci 1, 2. I'm no mathematician, so I couldn't say if that was right. One. It seems to be outputting the same thing. So 1, 0, 0, 1. Okay. Echo AB 0, 1. Da, 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 da. Yeah, I haven't got a clue. I was just basically going through and seeing what it. Okay, so here we go. Here's 10. I've been using it wrong. So 10. Let's. Always helps to read the documentation, doesn't it? So 10. There we go. Yeah, 0, 1, 1, 2, 3, 5. So that's the initial thing. 1, 2, 3, 5, 8, 13, 20. Yeah. Considering I used to pinch the maths books to get the answers at school rather than actually do the maths. So I used to have a master key to all the classrooms. I couldn't tell you if that was right or not, but it really did actually sort of give it some to kind of work all this stuff out. So I'm not entirely sure if that's working, or if there's any bashisms in that would not work with a regular script, but that's a sort of detailed look at getting all these LLMs installed and working, and additionally using Emacs and gptel as a front end to actually switch between the models. So again, if I want to switch to using another model, so I can kill that. If I want to switch to using another model, what I actually need to do is quit this deepseek-R1 and then run another model. So, okay, so if I want to switch back and run, let's run Zephyr. It's the one I didn't run. So what may happen here is llama run Zephyr. What I found sometimes is after you've been running a model and you switch back and use another model, it may crash. So let's check that. So post, so you can see here what's happened is error posted a EOF. You can see the other tmux window is now displaying desktop and not a llama server, which means it has crashed or stopped working, to be more polite. So pgrep ollama, see the process is still running. So pkill ollama, start that up again, run Zephyr, getting the error again, run it again. Don't know why it does that. Sometimes the other thing that can happen is it can sort of get stuck on this section here before it gets to the prompt. Okay, now that's worked. So we've got Zephyr started here, so we can switch back to Emacs. And what we'll do is gptel, I think, is it system prompt? No, it's the menu. So gptel menu, dash m zephyr, llama-server latest, close that window, gptel. There may be an easier way to do this, but as I said, I've only been playing around with it a couple of days. So we've now got llama ready, so that's the other thing. When a llama is actually working, it will say llama ready up here. If it says like waiting, you need to go and check if the server is still running. So we've got Zephyr here, we've got the programming, and we've got the same kind of deal. Default programming, writing. What we could do is get it to give a brief history of something. So see if it knows something like when was the Battle of Hastings? There we go. So you can see that's the writing. We could do things like summarizing text. So let's just grab that bit of code and say summarize this text. Control CE. See if that will help. So you can see here what it's done is it's just basically chopped off the first part here, and it's using that section there. So there is also, let's have a look at the gptel commands we've actually got available. So gptel, that starts the session. We got the menu, which is the how you can sort of you got the menu, which is up here, which I believe is that the one where you let's shift return. Let me just do shift return. This off. So visual mode, shift return. Okay, that is the sort of system prompt one, I think. So right, so we've got lots of commands here. We've got gptel, which kind of launches the interface. We've got the menu, and then the system prompt. So the system prompt is this one up here, I believe, that lets you switch between the different prompts. We've got a rewrite mode, so we can actually say gptel rewrite instead of me manually doing it. So let's see. I think I'm going to actually just paste that in down here, and I don't know if I can just do gptel rewrite. Okay. So what you've got here is when you do this rewrite thing, you've got full directive, rewrite instructions, rewrite, and these down here showing up dry run and inspect query, Lisp, inspect query, JSON. These are added because I added the bit of code for the expert commands in my init.el, and what these allow you to do is actually see the query that is going to be sent to the model in JSON. And basically what these usually use is curl to actually send a query to the server. So I think what you can do is actually press D, and what you can then do is you actually give it a set of instructions for the rewrite. So you could say rewrite this in one sentence. So I think you do rewrite as one sentence. So you can see after I've done that, so I pressed D and then said rewrite as one sentence, and it says rewrite. Then I can press R. You can see what it's actually doing is it's actually replacing the text. I mean, this, perhaps wasn't the best example, but it was just a bit of code there. So Okay, so you can see there it's actually rewriting it in place. So we have gptel, rewrite menu, system prompt, mode. So this is actually, you can turn on the mode. And what I found is it doesn't actually work in all modes. So like if you're in a shell script or something, you try and turn on the mode, it says, oh, I can't turn on the actual the mode in shell scripts or whatever. So it tends to work better actually in org mode. Rewrite diff, so control C, control D. So what you can see here is we actually have a diff showing the control XO, and what you can see here is it's actually got a diff of the original block of text and the version that we rewrote with the LLM. And I believe you can actually do neat stuff like if you're, for example, using Magit and you've committed a change and you've got a diff come up like this. Suppose this was a diff for a git push. What you can actually do is generate a commit message automatically based on the diff. So I think there's actually a way where you can actually take a diff and do things like generate a sort of a automatic git commit message. So I'll just close that. Come across and see what other ones we've got. gptel, rewrite diff, menu, mode, add. So this is add or remove buffers from gptel's context. Send, we've got send, abort, tools, ediff. I haven't tried a lot of these. Add files. So I believe there's a way some LLMs support adding a file or querying media. So regenerate, suffix send, next variant, rewrite next, org set topic. What that is let me just close that a sec. Org set topic, what you can do is run org set topic and it will set that particular headline be its own individual topic and not use any of the context from the previous prompts that you've sent it. So it's basically, if you were to write something like, what's the capital of Germany? And it output something, and then you'd create another prompt, and England, it would then it'd be able to contextualize what and England means from the previous prompt and go, okay, well, maybe he means, and what's the capital of England? When you say org topic, what it does is it sets it as its own individual prompt, not connected to anything else. So it wouldn't take into account the previous prompt, basically. And this is a way to sort of not muddy the waters with previous prompts. So we've got gptel, add, abort, tools, regenerate. So that was org set topic, mark response, rewrite diff, continue query, end of response. Yeah, I haven't org set properties, so that's another org related thing. Yeah, I haven't got. Oh yeah, gptel convert markdown to org, convert string from markdown to org markup. And so that's where maybe I saw that thing mentioned about some of the responses can be in markdown, and that it's possible to use pandoc to actually convert those responses from markdown to org format. Yeah, I haven't gone through a lot of these. So those are all the gptel sort of commands, and those are the sort of models we went through. So we've, to recap, what we've done is we've installed a llama. Let's, I could do the org present thing again, but I won't. So we installed Ollama. So on Freebsd, does pkg install Ollama. If you're on another system, ollama.com, download. Mac and Windows, as I believe, they've got a GUI to start the server, but you still have to use the terminal to pull down and run the models. I'm not sure if Linux distributions have got Ollama in. I'm sure something like Arch has. But if not, you can install Ollama using this command. And I really hate things that actually install stuff like this. It's just really dodgy. Running a command and just piping to your shell just feels wrong. But that's how you can download Llama. And then again, you've got the models up here, so you can actually search for embedding vision tools. You can see here is DeepSeek R1. I tried some of the Llama models, but I couldn't get them to run. So this is where you can search for models. Then you've got the GitHub again here. And same links down here. You've got Docker and stuff like here. And here's some of the model libraries. Again, important thing, you should have at least 8 gig of RAM to run the 7B model, 16 gig to run the 13B models, and 32 gig to run the 33B models. So you can see here, these 7B models here, I've got 16 gig of RAM, so I could run, I haven't tried running the 13 gig one. So, for example, I tried to run some of the Llama models, even if they've got like 7 or 8. I think it was the Code Llama. That was it. Code Llama. I tried to run Code Llama. As you can see, it's a 7B model, 3.8 gig, but it wouldn't actually run for me. Ran out of memory, and that may be one of those quantization things they talk about. Not sure. But basically, that's sort of a list of some of the models. When we had a look at DeepSeek R1 for the reasoning models, deepseek-coder, which did output some gibberish, but also did explain how a elist function worked. We had mistral, which is I think is that a meta thing? I'm not sure. And then zephyr. And finally, we had gptel. And as I said, this is a simple LLM client for Emacs, and it's just a lot nicer to use than using the terminal. And we also set up Google Gemini as an online version, so we've got a nice balance. We've got our Llama running locally, but we've also got Gemini running. And let me just see, where did I have my and again, this was the Emacs config. So just to recap on that, we've got the auth source, got gptel set up, Gemini set up, Ollama, the models, and org source block fixed there. But what I just wanted to do was have a look at some of those prompts. So one thing that it was useful for, let me switch back to Gemini. And Gemini, okay, let's set up. Tell, okay. Okay. It does actually work with Google Maps. So as I showed you, Google Gemini in the browser can work with various APIs for Google services like Maps, YouTube, and stuff like that. So in the browser, you could get summaries of a YouTube video or key moments in the video. What you can also do is actually use Google Maps API, and this does actually work using Google Gemini in Emacs. So what I can do, for example, is this prompt writing. I want default. Okay, create a CSV file with the location of St. John's Gate, London. Okay. So you can see there, it's actually giving me the location, the street, the city, and the postcode. What I can also do is this. A CSV file with the address, latitude, and longitude of St. John's Gate, London, and a short description. And this is using the Google API of the maps, I believe. And this is like actually using Google Maps and going to a particular address, and you're getting the little pop-up with the description and the address and latitude and longitude. Okay, so what we can see down here is we've got address, latitude, longitude, description. So we've got the address, the postcode, then we have the latitude and longitude, and then the actual description. And this is something I'm actually using for work sort of purposes, to automate querying things for Google Maps, rather than doing it manually. So that's just something else I wanted to show you with Google Gemini. Some things that work and some things that don't. So the other thing is I have tried using some of these models to query YouTube videos, and I think it was Zephyr got stuff completely wrong. So as I said, I think Zephyr was released a couple of years ago or something. And so when you give it a more recent video, it says, oh yeah, this was some video from like 5 or 6 years ago, which it wasn't. But that was just something I wanted to show you with Google Gemini while my mind was on it. That was the gptel setup with the authinfo and the format that you need to actually put in the authinfo, machine generative language.googleapis.com password, and the token that you get from that URL. And again, that is only needed if you're using Google Gemini, and it's not required for Ollama. So Ollama, you install Ollama, you run Ollama, and again, I was sort of starting it like this, but you can also use ollama-server, as I'll show you down at the bottom. So you run Ollama. You need to run Ollama to either pull down or run the models. So again, you have to actually have Ollama running and the model running to actually interact with it in Emacs. So this is a list of all the models that we installed again. DeepSeek R1, we pulled it. Ollama pull DeepSeek-R1:7B. You run it, Ollama DeepSeek-R17B. Same deal with the other one, the deepseek-coder, Mistral, and Zephyr. And again, that's how you kill the ollama-server. Check if it's running, pgrep ollama, pkill ollama. And as I said, finally, you can also start the Ollama with the following command, ollama-server. I haven't really been using ollama-server, so I couldn't really tell you what the difference between that and ollama start is, but I just thought I'd mention it anyway. So, and there was the Fibonacci script from DeepSeek R1, and gptel, and Ollama. So that's Ollama setting up the server, pulling down the models, running the models, setting up gptel with Emacs, making some nice configurations, setting the models that we want to run, also setting the buffer to be displayed in the same window, show you how to switch models. So hopefully that will get you started. There is somewhere, I think there is a list, Ollama supported GPUs. Yeah, now supports AMD graphics cards as well. Okay, so Llama supported GPU. So this is a list of supported GPUs, and I have a GTX 1650, which actually isn't listed here. So I was actually dubious about whether Llama would run on this machine, considering that it's a 6-year-old GPU, not particularly powerful one at the time. And what you have is NVIDIA GPUs, they have this thing called compute capability, and you need to check if your card's supported. So my card wasn't actually supported, but you could see that it would run, and it would output stuff at a reasonable pace depending on the model. Also, I am running OBS Studio at the same time and recording the mic with Arda. So there wasn't any, like, my computer didn't screech to a halt or become unresponsive actually while running on Llama or any of the models. So check the supported GPUs here, but if your card isn't actually supported, it still may work, albeit maybe not as fast as a more modern card. I'll put links to all this under the video, and hope that helps you get started with running some LLMs. And as I said, I've only checked 4 different LLMs because I've only been trying this for a couple of days, and I did pull down some others like Code Llama, and I think Llama 3.2 or something like that, but I couldn't actually get them to run. So I said that is one of the things. Sometimes you may sit there for an hour or two pulling one of these models down and then go and try and run it, and it doesn't have enough power on your machine to actually run it. So that can be a bit annoying. But there are lots of different LLMs you can actually try. I haven't tried any of the vision ones for analyzing images or video or that sort of thing. That's something to play around with next. But I'll leave it there and put links to all this under the video.